Hello everyone, this video is going to be about NoSQL. Okay, so NoSQL stands for not only SQL, so that means that it includes relational tables, but also NoSQL handles different formats, different structures, such as unstructured data and semi-structured data. Okay, so why NoSQL it's important for big data? That's pretty much because the design of NoSQL databases it's intended to scale horizontally. Then when you have a large volume of data, it's going to be easier to move all that information, all the data, to multiple nodes in a cluster of machines. So the design helps to be able to handle that volume of big data. Now, some examples of NoSQL where we have big data, for sure in social media platforms. So you can think of TikTok, Instagram, Facebook, in all the different platforms. So we have user profiles, right? And in each profile, there is like different formats of information. You have video, you have images, you have text, depending on the platform. So the way you store that data, which it's clearly unstructured, so it requires NoSQL. And in addition, here we have multiple Bs. Remember the 5 Bs. So we have large volume of data, we have velocity, right? We have a lot of variety also. So for sure, that's a good example of NoSQL in a context of big data. All right. So in NoSQL, these are like the four the biggest NoSQL structures or ways to store data. So we have key values, which we covered in previous videos. Remember the JSON files, right? So in JSON objects, we're working with key values. So you have like key value pairs. So for each key, remember there are some values, and that value is not unique. You may have an array or even another object nested in your file, right? In your key. So if you remember a little bit the structure, it's something like this. So it's like the quotation marks key one, right? And then we define the value for that key. We define the value for the key. Doesn't look good. Let me do it again. This is key one. I think it's better right now. Yes, the name of the key, and then the value. Let's say this is just a name. It will be a name. Say my name, Daniel. Right, and you can keep adding multiple information here, more keys with more information. Which again, it doesn't have to be like a unique value. You may have an object, an array inside the key value pair. All right, something similar to key values. We have documents. So even a document database, you can handle that with JSON or similar to the key value pair. But here you have like more complex structures. So typically you will have in the values, you will have maybe more objects, and then more objects inside the objects. Sometimes they are like big, really big. You have a lot of text, you have images inside. So in document databases, we consider that there is like more complexity when you want to access values. You need to perform like more nested operations. That's the only difference with key values. It can be like a special case actually. But there are other formats, not just JSON. Maybe XML can be also considered as one of these two. Right? I will show you examples in the next slides. Then we have column families. So in this format, the idea is to have like one big table with multiple column families. And the whole idea is that there will be only one key, like to identify the rows, but there are multiple column families. And the idea is like you can, when you are like querying your data, you don't need the complete table. Maybe you just want to see some of the column families, some of the columns, not all of them. So that saves a lot of time when we're processing these structures. So the pioneer in column families is Google Bigtable. I'm pretty sure that maybe some of you have heard of it. And the fourth NoSQL database type is the graph. So here, this type of databases, they are created when we have like a lot of relationships between our nodes or our observations. So it's useful for social network when you have different users and there are some connection between them. They create some content and there are some likes among the users. So you will create different connection types for the nodes in the graph. So when your data is heavily connected, so you can use graph databases to represent the connectivity, and especially when you're interested in some of the interactions of these entities in the network. Okay, so let's go over each of these structures. So as I said earlier, key values store and document stores, they are very similar. So in key values store, they are considered the simplest NoSQL type, and I would say JSON. It's popular already, but it's growing because it's simple. It's really simple to follow. I mean, if you compare it with XML, which has like more structure compared to JSON. Okay, and document stores when we like store more information. So let's go over some specific examples. So in the key value, again, the idea here is we don't want like deep queries here for the values. So typically with few operations you get access to the values once you use the key to go inside the database. So this is an easy example here. We have the keys, use the name of the user, I mean the identifier of the user. So user 1, 2, 3, then you have user 4, 5, 6, and user 7, 8, 9. Those are our keys, 3 keys. And for each key there is one value: John Doe, Jane Smith, Alex Johnson. So in this example, once you type the key, you get access to the value real quick. So that's an easy example of key value pair. But again, you might have some nested information, but not that complex as expected in the documents, right, databases. So this is more like document data. So we have like case, year, title. But for example, here in info, if you notice there's another object with information of directors, and again here this an array with multiple information. So it's like a nested object inside a nested one, right? So there is a little bit more complexity in document data. Again, using the same example of in a social network platform. So if you access to information of one user profile, so you have something like this. Like there are a lot of information that is nested, the images, text, right? So if you wanna get some specific values, your queries are going to be a little bit longer because you are going like deeper in the object. Okay, so let's discuss a little bit more about the column store. So these are two famous ways to handle and to work with column stores. That's Cassandra and HBase. So we will use HBase later in the course because it interacts. The H is for Hadoop, right? So it interacts with Hadoop easily to query our data, to store the data. So in the column store, let me show you an example. Maybe I think it's easier to follow the idea this way. So we have originally this table where we get the information about visitors accessing a website. So we have the visitor ID, right? The name, page views, last visit, and city. So instead of having like these columns disconnected, a good strategy can be to create some column families. The idea of the column families is to identify which of these columns are related, right? So for example here, we might have the column family visitor info. So we have the name and the city, that's the visitor info. Please notice that there is an ID, a unique key right? In big tables, in the column stores, there is typically one key. It's not like in relational databases where you might have several keys. Now here there is only one, right? And here we're identifying two column families. So the first one is the visitor info, and the second one is the visit stats. So it's just page views and last visit, right? That's the information. And again, the key here is the same. It's the row key. So we can put them together in the table. So the idea is to also we will have the row key, right, which is the same. Then we might have the column family one, which is visitor info. So these two columns, that will be the visitor info. And then we will get the column family of the visit stats. So it's a big table, right, with a single key. And the idea here is like you can keep adding more families of columns, right? But your table is going to grow mainly horizontally, right? So the key idea here of column stores is like, since you have column families, each family means columns that they need to stay together. But if they belong to different columns, to different families, then you can split them. And that's the idea when you have a lot of information and you want to distribute your data. So it is important to know, okay, which information should stay together, but which information can be split. So that's the key idea behind the column stores, to define the columns that need to be together and those that can be split at any time. So Google Big Table was the pioneer in this type of databases, but HBase and Cassandra, those are like like they are open, they are free. But it's the same idea. It's the same idea. All right, and the final database type is the graph databases. We mentioned before that is when you data it's heavily connected. So you have interconnected data. So you want to create relationships, right? Links between nodes or entities. So one of the examples here for sure is that if you go Neo4j, it's the one of the databases manager that you can use for this type of data. And for social network, it's really important to like the relationship between the users, between the different profiles, right? So in that context, the links are important to see like how they are connected, because you want to analyze that to make recommendations, right? Same thing with recommendation systems, Netflix, YouTube, right? When once one video, once you complete one video, then you get some suggestions, right? So the recommendation system, they can be handled with this type of database, with graph databases. So this is how it's going to look in the context of a social network platform. So you have the individuals, right? And then you have more different links, friends with, but also the posts can be like different links, right? And then you can see like, okay, who's friend with who, and that's how you can create some suggestions, right? In this thanks to this structure, right, where the connections, the links are highlighted. Okay, so far we have covered 4 types of databases. It's just a quick introduction. We'll go in more detail in this database, especially documents, key value pairs, also the column family, column stores. We will get a little bit more of graphical databases. All right, so when we're working with big data, there is a theorem, the CAP theorem, which describes that there is a trade-off. So it's difficult. It's desired to get these 3 attributes, but sometimes, and that's the theorem, you can keep only 2, at the maximum level. So what are the attributes? Each of these letters stands for one of the desired attributes. So the C is for consistency. So consistency means all clients have always the same view of the data. So in some contexts, consistency is a must. For example, imagine financial services. So when you access your, like online account, so you want consistency for sure, right? So every time you access that information, or someone else access that information in another bank, when they are the same bank, when they are trying to make a decision about to approve or not a credit for you, a loan. So in that context, of course, consistency is a must, right? Then the another desired uh, attribute is availability. So every request gets a response, even if it's not the most recent. So this is really important in social network platforms. So every time, like the users kind of like enter the app or this platform, the user is expecting to get something, right? To get a response. Again, even if the feed that person's get is not the most recent, so availability is key in that context. Partition tolerance means the ability of the system to continue working despite some uh, problems, right? So it is important to ensure reliability of the system. So these three are desired, but again, the theorem says that to achieve the three of them at the same time is difficult. Typically, you will achieve two, right, at the maximum value, and the other one is not going to be perfect. So you need to prioritize depending of the context. Okay, so there are some considerations when you are choosing NoSQL in big data. So the first one for sure is you need to check your data, like the structure of your data. So what type of data you are working with. So remember the different databases that we cover, right? So scalability. So it's important to understand how your data is going to grow. We expect that it can be scaled horizontally. That's desired, not vertically, right? Remember, that's desired when you want to distribute the storage and the processing. In the previous slide, we just discussed the CAP theorem. So there will be some trade-off between consistency and availability, for example. We provide examples in the financial system. Consistency is desired, while in social media, availability is prioritized. Latency and performance. So it depends like whether your system is facing directly the customer. So if that's the case, then you want like high performance, low latency. The idea here is like once you request data or perform something to process the data, is how long does it take, right? So depending on who's using the system, depending on the context, it's going to be critical, this performance. Okay, there are some challenges of NoSQL in big data. So the trade-off that we just discussed, right? The CAP theorem. Complex querying compared to SQL. In SQL, remember that SQL has been around like for almost 50 years, so it's a well-known language. So in general, it's simple to query. Actually, if you are using generative AI, ChatGPT, Gemini, for them, it's pretty simple to assist you in the queries. But in NoSQL, it might be some like more challenges depending on the type of database that you are using. It's improving in some cases. They look really similar to SQL, but again, there might be some more like complex querying. Okay, the complexity of the model. So remember that in NoSQL, you got to be careful because even though you're handling unstructured data, at least you need some planning on how you're gonna store that information, especially when you're planning how you're gonna scale that in the future. So it's important to kind of like plan ahead that even though you're facing complexity, you need to ensure that that complexity can be handled with the system that you're designing. And the last challenge here is the tooling and ecosystem. So NoSQL, it's growing, it's big, but again, some tools like the analytics part, the EDA, it's not that strong yet. I mean, there are some good methods, but they are not like mainstream compared to other cases. For example, when we're working with relational databases or just with simple tables, Excel, Power BI, they are like really popular and well-established tools. In some cases, not the best, but again, they are really, like they are clear. Everyone understands the basics. But in NoSQL, it's not the same because there are like different tools, but and in some cases they are not that popular. So that's why it's still growing. It's not mature compared to the other scenario. So the conclusions of this introduction of NoSQL databases, the first one is that they provide scalability, horizontal scalability, flexibility, especially in the way we store data. It's not like like remember that in the tables, which is there are some rules. Here, to be honest, you have more flexibility. Okay, so there are, we mentioned four different NoSQL databases: document, key value, column family, and graph. And they serve different needs in big data. So it's important to choose the correct one, depending, of course, of the context and the type of system that you're trying to design. Be aware that structured data also can be handled with NoSQL, right? Because when you read NoSQL, maybe someone can understand can think like, okay, there are no tables or NoSQL. No, it's not only SQL. So that I think that's important to emphasize that point again. All right, so NoSQL databases are a key part of big data for the reasons that we just mentioned in this video. So it's important that you get familiar with all of these four structures. So in the upcoming videos, we'll be working a little bit more in each of them, so you can get familiarity. You get used to it, and you will understand how we're going to connect those different databases with with the distributed storing, and also when we process our data in parallel. So it will make more sense once you understand these data structures. Okay, I'll see you in the next video.